So let us start with our today's session. So basically in the yesterday's session, as we discussed about the regression models, okay, and in the today's session we'll talk about the clustering as well as the classification model, okay. So let's get started. So basically as we all did these things yesterday, okay, and see this is our today's agenda. So in the today's agenda we'll be talking about the classification technique, and as we know, one of the simplest classification technique is nothing but the k nearest neighbor classifier. And second one, we have the unsupervised learning. In that we are gonna talking about the clustering method, which is here. Okay, we'll talk about the two methods. First one is the complete linkage and another one is the single linkage. So basically here you will see that in the clustering we have two different, as we so many have linkage method in the clustering, but here, okay, we'll only talk about these two methods, okay. So first we'll talking about the k nearest neighbor. So see, as you know, okay, yesterday, basically as we know in machine learning we have three different main types, okay. What are those? First one is the supervised learning, then we have unsupervised learning, and third one is a reinforcement learning, okay. So basically most of the time we are dealing with the first two methods or the first two categories of the machine learning. First one is the supervised learning and another one is the unsupervised learning, okay. So in the supervised learning, as we know, we have the label data, okay. Means in our data we have the some input columns, okay, and we have one output column. So based on that we are gonna build the model, okay, for predicting a numerical value, means the regression type of problem, or the we are gonna predict the class label, which is nothing but the classification type of problem. So this is a k nearest neighbor, okay. This is, you can say that this is the simplest machine learning algorithm, okay, based on the supervised learning technique. And see, basically in the k nearest neighbor algorithm, basically it assumes the similarity between the new cased, or you can say that the new data points and the available data points, and the then it just put the new data points into the category, okay, that is most similar to the your available categories, okay. So now here we are gonna here we are talking about the classification technique, okay. So yesterday as we talk about the regression problem, so see, in the regression problem we are predicting the model for predicting the numerical value, okay. So see, now here in the with the help of k nearest neighbor, okay, we are building the classification model, which means in our data, okay. So in the data we have input data as well as the output data. So in the output data, okay, instead of numerical value now we have the different classes, okay. We may have two classes, we may have three classes, we may have n classes, okay. Like let's say if we have two classes in our output data, like 0 1, okay. So here we want to build a model for, okay, to find the particular class 0, either 0 or 1, okay. And see, we are using this k nearest neighbor for regression as well as the classification type of problem, okay. And it is a non-parametric algorithm, which means it does not make any assumption on underlying data, okay. And you can say that it is also called as lazy learner algorithm because it does not learn from the training set immediately. Instead, it stores the data set and at the time of classification, okay, it performs an action on the data set. Okay, and you see the k nearest neighbor algorithm at the training phase just stores the data set, and when it gets new data set, then it classifies that data set into a category that is much similar to the new data set. Okay, so let's take a small example. Okay, so see here in this example, suppose we have an image of a creature that looks similar to cat and dog. Okay, but we want to know either it is a cat or dog. So for this identification, we can use the k nearest neighbor algorithm. Okay, as it works on a similarity measures. So our KNN model will find the similar features of the new data set, which means this input data set, okay, to the cats and dogs images. And based on the most similar features, it will put it in either cat or dog category. Okay, like this. Okay, and then we'll get the final output. See, so after that, why do we need k nearest neighbor algorithm? So let's say suppose there are two categories in our data set, like category A and the category B. Okay, so simply I just make the scatter plot, okay, between our like using our data set. And here my intention is to just say, like, my intention is to just classify these new data points, okay, into each of these category. Okay, so see, we are like, basically in my data set we have two categories. Okay, so first I am going to find the similarity between these new data points and each and every data point. Okay, like this. Okay, let's say, see here. Okay, so this is our new data point. Okay, this is our new data point. Okay, and I want to classify this data point into each or one of this category, either category A or the category B. So see here, few data points which belongs to category A and few data points which belongs to category B. So now in the first step, or in the initial step, okay, I'm just trying to calculate the distance between each and every, okay, the data points, okay, to the new data point. See here, first I am just finding the distance between the points and these new data points. Okay, see, so after finding the distance between all the actual data points and the new data point, see, now here I got all the distances, okay, these values. Okay, now after that I'm just choosing this k value. Okay, now if my k value is, let's say, 3, okay, so here you see that these 2 points, okay, sorry, so here these 2 points, okay, and this 1 point is very much close to this new data point. Okay, and see, these 3 points, okay, these 3 points are very close to this new data points. You can say that this is a neighbor. Okay, these 3 points are the neighbors of this particular new data point. So simply now here I know that these two data points, okay, are from the category A. Okay, and here you see only one neighbor is from the category B. So you can say that these 2 points, from these 2 points, by the majority of voting for this category A, so you can simply add these new data points into the category A. Okay, so this is a very simple algorithm. Okay, which is nothing but the k nearest neighbor. Okay, then you see here, after that, how to implement k nearest neighbor on a data set. Okay, so for that purpose, okay, we have to go with this certain steps. So first, here first we need to select the number k, okay, which is nothing but the neighborhood points. Then in the second step, we have to calculate the distance, okay, by using various distance formulas. Okay, but like we are preferring the to calculate the distance or the similarity between the data points you using the Euclidean distance. Okay, so we'll talk about this, what is Euclidean distance, okay, some like in this session, okay, like after some time. Then in the step 3, we are just taking the k nearest neighbors, okay, as per the calculated Euclidean distance. Then in the step 4, among these k neighbors, okay, we'll just count the number of data points, okay, which belongs to each category. Okay, then in the step 5, we'll just assign the new data points to that category for which the number of neighbors is maximum. Okay, and you can say that our model is ready. Okay, so in simple words, simply we are just using k nearest neighbor, okay, without any parameter, okay, without any assumption, and will simply stores our training data, okay, at the time of training the model. Okay, and then at the time of making the predictions, okay, on the new data, so at that time we are using all the previous data points, okay, to find out the distances, and then we'll try to find out the k neighbors to that new data points, and we'll try to classify that new data points into one of the category. Okay, so see here in this example, okay, am I audible, guys? Okay, just drop the message.
Yeah, yes, sir.
Okay, so see
Sir,
in the KNN, okay, let's see like the one example of k nearest neighbor with different k values. Okay, so see in the first step, simply we have the data, okay, and here we have the new data points. Okay, so this is my new data point, so I just want to classify this new data points into one of this category, okay, either category A or the category B. Okay, so for that purpose, here I'm using the distance formula. Okay, like this is the Euclidean distance formula. We have so many different distance formulas. We have the Manhattan distance formula, we have the Minkowski distance formula. Okay, like this we have so many distance formula. Okay, with that we can simply find out the distance, okay, between the two data points, but we are using Euclidean distance most of the time. So see here, okay, we have two data points in the two-dimensional space, okay, point A and the point B. Okay, with the like order pair x1 x2 sorry x1 y1 and the x1 x2 y2. So see how to find the distance between these two data points by using this formula Euclidean distance. Okay, by using this distance to find the distance between the point A and the point B. See, simply by using the square root, in the square root just x2 minus x1 square plus y2 minus y1 square. Okay, if you have the three like data points in the three dimension, and if you want to calculate the distance between the those data points in the three dimension or in the higher dimension, okay, then only you can use this Euclidean distance formula to find out the distance between the you can say that the data points in higher dimension. Okay, so see here, let's say, okay, now if you have the like points in a 3 dimension, so then you may have, okay, so you may have the point like this. Okay, let's say the point A, okay, x1, y1 and z1, and you may have the point B as x2, y2 and the z2. Okay, so simply again by using the same Euclidean distance formula, okay, so see, we are just finding out the distance. Okay, the x2 minus x1 bracket square, okay, then y2 minus y1 bracket square plus z2 minus z1 bracket square. Okay, and we are just taking the square root of it. Okay, so simply by using this same formula in the higher dimension, you can find out the distance between the two data points here. See, so again, if you have the higher number of dimension, let's say n, then only you can find out the distance between the two data points in the n dimensional space. Okay, by using this Euclidean distance, and like this is a very simple to calculate, so that's why we are just preferring this Euclidean distance. Now after that, see, now after by finding the distance between these new data points and each and every our actual data point, see here we just find out the 5 neighbors, okay, of this new data point. So see, in the 5 neighbors, 3 are from category A and the 2 are from category B. So in simple words, we just by using the majority of voting, see, 3 data points are from the category A, so you can say that this is the majority, like majority of data points are belongs to the category A, so you can say that this new data points is also belong to the category A. Okay, so here you can see that after that, okay, so this is how you can just make the classification using the k nearest neighbor. Okay, so here we just use the k equal to 5 value. Okay, as a, here we just use the 5 neighbors to find out the classifier. Okay, now see, this is how we just we are gonna just do the steps for the k nearest neighbor. Okay, first we have the initial data points, okay, in anywhere, okay, on the plot. Then here after that we just calculate the distances, okay, of these new data points and each and every data point. And then after that, here you see that I'm just finding the neighbors, okay, either 1, either 3, either 5, either 7, okay, in the like odd manner. Okay, now see, when I'm using if I use the k value equal to any even number, let's say 2, 4, 6, 8, okay, or 10, 12, like this. So if I use any like k equal to even value, let's say 2, so then see here, let's say these two data points are neighbor for this new data points. Okay, and here I am using the value of k equal to 2. So in that case, one data point is from the category A and one data point is from the category B. So now here model is not able to make the classification or make the prediction about this particular data points. Okay, means this new data points is belongs to which class. Okay, because equal number of neighbors, okay, to this new data point. So that's why we are using the value of k equal to any odd number instead of even number. Okay, so that is a, you can say that the note for this k nearest neighbor. Okay, and then here you see that like if we choose a let's say any low value for the k, let's say k or the k equal to 2, so it can be noisy, okay, and can lead to the effects of outliers in the model, okay. And you see the large values for k are good, okay, but many times it may find some difficulties, okay. So then let's talk about some advantages of the k nearest neighbor and the disadvantages. So basically it is very simple to implement on the any data set. Then it is robust to the noisy training data, and it can be more effective if the training data is large, okay. Because when our data is large, okay, so then we have so many data points, okay, in the training data set, okay, and then we can find out the best neighbor for the new data point, okay. So that's why if the training data is large, so then our model would be great. And let's talk about the some disadvantages of k nearest neighbor. Basically it always needs to determine the value of k, which may be complex sometime, okay. Because see, if our training data is large, okay, so at that time for finding the best value of k, okay, which one is the best value of k, so at that time we have to build the model for each key value, okay. So let's say in my data set we have the like some millions of data point, okay. So then I want to build the model, okay, for each k value, for k equal to 1, for k equal to 3, like this, okay. So at that time it may be complex to find the k value. Then the computation cost is high because of calculating the distance between the data points for all the training samples, okay. So if we have the millions of data point in the training data set, so see, then if we have to classify one new data point, so for that classification, okay, for that particular one point classification, we need to calculate the millions of distance, okay, distances, okay, for that particular point to classify that particular new data points, okay. So at that time computation cost would be high, okay. So this is all about the k nearest neighbor, and it is a very simplest algorithm, okay, of the machine learning. So that's why here I choose this algorithm to explain you all, okay. So now let's go and try to apply this, okay, on various different data sets, okay. So see, here you can see that again, as we yesterday like talk about these different libraries which are important libraries in the like for the machine learning purposes, okay. So see here, first let's go and clear all the outputs. So see here, again I am using the NumPy library, Matplotlib library, and the Pandas library. As we know, we are just using the NumPy library, okay, to create some n-dimensional array or array related work, okay. Then we are using again same NumPy library for creating the, you can say that, for some statistical analysis. So, okay, okay. And then we are using this Matplotlib library to just build the like so to, okay, for doing some data visualization stuff. And finally we are using this Pandas library to, okay, for the data analysis and for data pre-processing as well as data wrangling stuff, okay. So let's run this. What's the problem? Okay, nothing. Wait, let's go and is the problem? Actually, it is taking some time, okay, to just remove all the outputs. So instead of that, let's go and go with the our code instead of just removing all the output. So let's go and first let's import all the libraries which are important, okay, for our analysis. So see here, I just imported few libraries first, okay, and then after that, here you will see that I'm importing the data, okay, which is nothing but the users data. Okay, so basically in my data set, what's the problem? Actually it's still running, okay, this particular cell as well as this cell. Actually it's what's okay, three bubbles. Okay, so 1 second and see is it working or not. Yes, it is. Okay, it is working. Let's try to run this and see. Okay, it's also showing to wait. Okay, so let's just see this and let's go here, select this and again reopen the Jupyter notebook. Done. Okay, and see here. Okay, okay, and let's see. Yes, it's working now. Just failed. Okay, done. So see here, we just imported few libraries here, NumPy, Matplotlib, and the pandas, and after that, see, just wait. What is the problem? Okay, it is here. You can say that it is running. That's why this is particular cell is not running. It is taking so much time. Oh, done. So see, after importing the these libraries, let's go and read our data, which is nothing but the users data, and here we'll try to see the first 5 entries of our data set. Okay, so see, by using the head method here, we just, okay, we here we have the first 5, or you can say the top 5 entries in your data set. So basically you have these many columns: user ID, gender, age, estimated salary, and the purchased. Okay, so from this user ID, gender, age, and estimated salary, okay, you have to build the model for this particular class, okay, for this particular column, which is nothing but the purchased column. Okay, let's say this is particular, okay, this is particular product, Okay, and by using this different information of the customers or the users, the will try to, okay, just build a classification model. Okay, so see, user ID is not important here. Okay, so like we have the three different columns. Okay, so here, now here we are gonna use only two columns, okay, which are numeric columns. First one is the age and estimated salary. Okay, here is to just show you how to build the model by using the k nearest neighbor. Okay, because see, after converting the gender column into the 0 and 1, okay, by using the dummy, okay, like by using the like dummy variable, so you see that here we just got the 0 1 value. Okay, and see, in the k nearest neighbor we are just like finding out the distances. Okay, so this does not gonna make sense, so that's why we are just using the two numeric columns, which are, first one is the age and second one is the estimated salary. So see, here we just split the data into input data, okay, second index and the third index, okay, columns we are just taking in the input data. So see, this is the second index, this is the third index, okay, of the column. So basically index starts with the 0 in Python, so that's why this is a 0 index column, this is a 1 index column, this is a second, and this is a third index column, and last index. So we just say as this column is nothing but the target column, or you can say that output column. So let's go and run this particular cell and see, this is how our input data looks like. Okay, so see, in the input data, see, we have two different columns, okay, age and estimated salary. Okay, but and here you will see the output column. Okay, so basically in the output column you will see the different values, okay, in the form of 0 and 1. Okay, this is a 0 means no purchased and 1 means yes. Okay, so let's find out the like some information about the data set. Okay, so with the help of info method, okay, here we can check that the in the data, are there any null value or the missing values, okay, present or not. So see, total we have the 400 entries in our data. Okay, from index 0 to 399, and in each column, okay, we have the 400 non-null values, which means there is no null value in our data. Okay, and you see the data types, okay, the column data types. Okay, so at the time of creating variables yesterday, so see, we saw the type of the variable, okay, like integer, string, or the like float value. So see, you see the object here. Okay, so object is nothing but the string column. Okay, so basically here we have so many entries in one column na? So that's why here we just add the object data type here instead of string. Okay, and with the help of describe method, okay, you can get the summary of your data set. Okay, see, this is the summary of your data set, and okay, you have the count of your data set, okay, total entries in your each and every column. So you have, see, 400 data points in each and every column, as well as the mean for each and every column, then standard deviation, then see the minimum value, then the 25th quartile means the first quartile, then the median value means the 50th or the second quartile, then the 75th quartile means the third quartile, and the maximum value. So see, now, okay, we just took these two columns, okay, for the analysis for building the model of k nearest neighbor. Okay, so see, in my data set, the age column we have, and the range of age column is between 18 to 60. Okay, and the range of estimated salary column is starting from 15,000 to 1,50,000. Okay, so you see the drastic change between these two columns range. Okay, now you can just find out the difference, okay, of the range by using the mean value as well. The mean value for the age is 37 and the mean value for this estimated salary is 69,742. Okay, so you see the difference between the mean value for these two columns. Okay, and you can also check the difference or the variance between these two columns by using this standard deviation value. Okay, the standard deviation for this age is 10 and the standard deviation for this particular estimated salary column is 34,096. So you can say that this is a variability, okay, in your data set. Okay, or you can say that in the data points. So now, instead of go and create the model by using these original values of this age and estimated salary column here, okay, then we'll here will be facing one problem. Okay, see here, the age values, okay, are in the 2 digits, but the estimated salary columns values are in the 5 or 6 digits. So here one column, okay, is totally dominating column. Estimated salary column is the dominated column in the data set because the range is quite high. So if we build the model by using these two columns, so at that time model is just influenced by this particular column, which is nothing but the estimated salary column. Okay, so for that purpose, okay, we need to transform our data. Okay, so in the data science project we have certain steps. Okay, first we go with the data pre-processing, then data visualization and EDA, exploratory data analysis. Then we'll go with some like in the data pre-processing step itself. Okay, here we'll just try to transform the data. Okay, if there is a like higher variance between these two data points, okay, or the two columns. So see here, here we got the like higher difference between the ranges of this age and estimated salary column. Okay, so that's why we are just using some data transformation method to transform this two data set, okay, or the two columns in the data set. Okay, and we are just transforming this column ranges from any range to any particular certain range. So see, first we are just using the sklearn. Again, the sklearn, as we know, this is a very good library for the machine learning, okay, in Python. Okay, here we just extract this particular module, which is nothing but the model underscore selection, and by using these we are just importing this train underscore test underscore split method. Okay, and after importing this particular train test split method, okay, by okay from the sklearn, so see here we created the four subset, okay, of the data set by using this single code. So see here we applying the method on the input data and the output data, and here I want the size of the test data is 25% of overall data. Okay, means I'm extracting 25% of the random 25% of random data points, okay, from the original data. Means total we have 400 data points. Okay, so 25% of the data set, okay, or the 25% data points means we are just extracting the 100 data points from these 400 data points. Okay, so in the test data now we have the 100 data points, and in the train data we have the remaining 75% of the data points. So let's go and run this particular cell, okay, for splitting the data into training and testing data set. And see, okay, in the next cell we are just applying the data transformation method, which is nothing but the standard scalar method on our data. Okay, so basically here we splitted the data into four different data set. Okay, so first and the third one means X-train and the Y-train. We are using this two data set, okay, for creating our model. Okay, we are building the model by using these two data set, X-train data, this one, okay, and this one, X-train and Y-train. Okay, so after building the model, okay, we are making the predictions by using the new data set. So this is my new data set, okay, X test. And after we got the predicted values for this X test data set, okay, we'll just compare those predicted values by this Y test data set, okay, to find out the accuracy of our model. Okay, so that's why we just split our data set into these four subset. Okay, so see here again we are using sklearn dot pre-processing library, sorry, module. Okay, this is a module, this is a library. Okay, in the library we have so many modules, okay, in one library, and in that module we have so many methods. Okay, so in the pre-processing module we have the standard scalar method. Okay, so see here we just store the standard scalar method in the st underscore x. Okay, and see here we are just applying fit underscore transformation, means just by using this standard scalar method just transform our train data and transform again test data. Okay, so let's go and run this particular cell and see after running that particular cell here. See, this is how our data looks like. Okay, now you see we just transform the range, we just transform each and every value in our data point. Okay, in our two columns, age and estimated salary. Okay, originally our data is looks like this. Okay, but we transform our data, okay, which is the input data, and now our data looks like this by using the standard scalar. Now you see here standard scalar means here we just apply the standard normal distribution. Okay, we just use the central limit theorem, okay, for applying standard normal distribution on this data set. Okay, so central limit theorem says that if we have the data points, okay, which is more than 30 data points, if we have more than 30 data points from the certain data distribution, so you can transform the data distribution of that particular data, okay, by using the center limit theorem. And the formula for transforming the data by using the center limit theorem is nothing but the x minus mean of your data divided by the standard deviation of your data. Okay, so by just calculating the mean and standard deviation of your data and just subtract mean and divide by standard deviation, okay, you will get these values. Okay, these values. Now you see the range of this value is lies between -3 to +3. Okay, total 99.73% data points, okay, should be lies between this range -3 to +3. Okay, because this range -3 to +3 range is nothing but the range of standard normal distribution. You can just go and search for the standard normal distribution, because standard normal distribution is very important. Okay, it's playing very important or crucial role in the machine learning. Okay, so here we just apply standard normal distribution on our data and see we just transform the range or the data points, we just transform the range and convert the two columns range into the same range, see -3 to +3. Okay, see, and after that, see here we are just using the k neighbors classifier. Okay, so basically again by using the sklearn library sklearn.neighbors, okay, this is a module in this sklearn library, and from these neighbors we are just importing k neighbors classifier. As we know, KNN works for the classification task as well as the regression tasks. Okay, so that's why in the neighbors we have two different methods. First one is a classifier and another one is a regressor. Okay, so if you just add the regressor here instead of classifier, okay, so you can easily find out the regression model, okay, by using the k nearest neighbor. And see here, now I'm creating the model. See here, n neighbors equal to 7. So basically this is the parameter for setting the k value, n neighbors, which means the k value. So here I'm setting the value of k. So here my k value is 7 and I'm using the Minkowski distance. Okay, so again, if we have the, let's say, like higher dimension, okay, three or more than three dimension, so you can say that you even use Euclidean distance or Minkowski distance, because especially Minkowski distance we are using for higher dimensions. Okay, like not most of the time, but you can like cross check. Okay, and which particular evaluation matrix gives you a higher accuracy, you can go ahead with that particular distance formula. Okay, so here I am using the Minkowski distance to find out the distance between the points. Okay, and see here, after building the classifier, we are just fitting the classifier on the train data set. Okay, see, in my train data set we have few, means only two columns, which are input column, age and expected salary, and we in the wide data we have the purchased column. Okay, so let's go and run this particular cell. So see here, after creating the model and after fitting the model on the data set, see here, I'm gonna make the predictions on first train data and then test data. So see here, I'm using the train. Okay, I'm just using the train data to make the predictions. Okay, and after that, again by using the sklearn library, you see the importance, okay, of the sklearn libraries. Okay, we can split the data by using train and test. We can just extract the confusion matrix and the classification report again by using the sklearn. We can transform the data again by using the sklearn. We can extract the model for particular classification as well as regression by using sklearn. Okay, means all the task of machine learning you can do it by sklearn. Okay, without except one task, which is nothing but the reading data. Okay, so see here, I'm importing the confusion matrix and the classification report. Now as we know, in the yesterday's session, in the regression problem we use, okay, R square, which is nothing but the evaluation matrix for the regression analysis. Then we use the adjusted R square, we use the log likelihood, we use the F statistics, we use the AIC, Akaike's information criteria, we use the Bayesian information criteria, and then we go with the that table 2, okay, in the summary of regression. Okay, and then we also use RMSC, okay, by using the sklearn library. So in the regression we use lot of evaluation matrices to find out which model is best model. Okay, so here as well, okay, we are using confusion matrix and the classification report to find out that particular which model is the best model. Okay, so see, by using the confusion matrix, again I'm just using the actual our output data and the predicted data. Okay, so see here, I just store the predicted values, okay, of our data, which is the train data, by using this wide train predict. Okay, and I'm comparing now the actual value and the predicted values, and see in the classification report again I'm doing the same thing. Okay, but these two are giving me a two different output. Okay, see, confusion matrix is this. Okay, and this is a classification report. Okay, so now this part is very much important, guys, huh? Because it's very easy to build the model. Okay, because here we just use these three line of code. Okay, or even you can just use like this. Okay, just cut and paste here, and you simply go ahead with this. Okay, only two line of code, just by importing your classifier and running the code. Okay, but to find out the best model, okay, here we need to interpret the confusion matrix and the classification report. So see, in the confusion matrix we have four values. Okay, in terms of like we have the matrix of this. Okay, so in the name itself we have a word confusion, which means this is a little bit tricky. Okay, so see here, this first we have the 176 value. So basically, let me just use the drawing tool again so I can. So see, first we have the one value as a 100, and it's not working properly. Okay, 176, you can just, okay, it's not, okay. So we have first value as a 176. It's not working again. Okay, anyway, let's go with this thing only. Okay, actually here, okay, we have another tool which is whiteboard. Okay, let's use this particular confusion matrix and let's draw this confusion matrix here. Okay, first we have 176 value. Okay, see, first we have 176 value, then we have 13605. Okay, 13605. So basically this is the confusion matrix of our model. So see, here we have the one value which is nothing but the 176. This is nothing but the true negative value. You can note it down, guys, because this is very important part. Okay, true negative part. Okay, now see here, why true negative? Because for creating this confusion matrix, we just compare the training actual training data and the predicted data. Okay, because we make the prediction by using the input train data, so we got the predicted values. Okay, and we just now we are comparing the actual and the predicted value. So by comparing actual and predicted value, we got this true negative value, which is nothing but the 176, which means total, okay, these 176 data points actually are belongs to class 0, and model predicted that 176 these data points are from class 0. So you can say that first actual 0 predicted as a 0 means this is the true negative. You can consider as a like 0 class as a negative class and the 1 class at the as a positive class. Okay, so this is a true negative value. Now in the next diagonal value we have the 105 value. Okay, so 105 value means this is a true positive value. Okay, so basically this is 105 value means the true positive value, and you can see that we have 105 values are from the one class and predicted as a 1. Okay, class 1. So this is a true positive value. Now we have the 13 and 6 value. This is the non-diagonal values. So first we have the 13 values. So you can say that this is a false positive class. Okay. Now why false positive? Because actually these 13 data points are from the class 0. Okay, but model predicted as these 13 data points are from the class 1, so that's why false positive. Okay, this is a wrong prediction. Okay, 13 data points, okay, are the, you can say that, misclassification or the wrong prediction. As well as you see the 6 value, which is the false negative value. Okay, so see, so basically 6 data points, okay, are from the class 1, but model predicts as a these 6 data points are from the class 0, means actually they are from class 1 but predicted as a class 0, so this is a false negative. Okay, so see, this is a interpretation of these 4 data points in the confusion matrix. Okay, so you see this is little bit tricky, so that's why here we have the term as a confusion matrix. Okay, you can just repeat these steps, okay, or you can watch this video. This recorded video will be just uploaded on the YouTube. Okay, so see, okay, so see, this is a confusion matrix. Okay, this is the true positive, this term is a true negative, this is a false positive, this is a false negative. Now let's go and talk about this classification report. Okay, so see, in the classification report we have the accuracy. Okay, model says that I use 300 data points to build the model. Okay, because 300 data points are belongs to the train data and only 100 data points are belong to the test data. So here I used overall this 300 data points on, and I got the accuracy as a 94%. And see, 189 data points are from the class 0 and 111 data points are from the class 1. Okay, now you see the precision value, recall value, F1 score value. Okay, so these three are the evaluation matrix, okay, for the classification task. Okay, as well as this one. Okay, so we have to check these 4 terms, okay, to find out that which model is the best model. So see, first precision value is the 97% or the 0.97, so you can simply say that, okay, this is the precision value. Now how to find this precision value? So we have one formula for finding out this precision value. Okay, by using these terms, okay, by using this term true positive, true negative. Okay, see, this is our true negative, this is a true positive, this is a false positive, and this is a false negative. This is our confusion matrix. Okay, and what is the precision here? Precision is nothing but the true positive, okay, for this class, positive class, guys, divided by true positive plus false positive. Okay, so this is the precision value. So see here, okay, now for this class, for negative class, what is the precision value and how to find this? So see here, precision for class 0 is nothing but the, this our value, this 176. Okay, 176 value, okay, divided by again 106 value. Okay, and finally we have the, Okay, and finally we have this value. Okay, see, we have the 6 value. Okay, so this is the false negative value. Okay, and let's run this and see the output of this. Okay, so now let's go and run this. So see, this is the output. Okay, 0.97. So here I'm just round this, use the round method. Okay, to just store the value by only 2 decimal points. So see, here we got the value for the negative class. Okay, the precision value for the negative class is a 0.97. Okay, which means, okay, basically this precision value means our model is correct. Okay, 97% of times when it is trying to identify negative samples. Okay, because here we just find out the precision for class 0, and class 0 means the negative class. So you can say that our model is correct 97% of the time when it is trying to identify negative samples. Got it? Now you can find out the recall. Okay, recall for class 0 by using this. Again, you have to use here the true negative value, which is 176. Okay, plus divided by 176 plus, again, here instead of false negative, here we have to use the false positive. So that's why here we use the false positive term and recall for class 0, and I want the output only by 2 decimals. Okay, and see, the output is 0.93, which means now here this is the recall value. Okay, which means that means the interpretation of this particular means our model identified 93% of negative samples correctly. Okay, because here we just find out, okay, the recall value for this particular class 0 class. So you can say that our model identified 93% of negative samples correctly. Okay, so this is the interpretation of the recall for this particular class. Okay, and lastly we have the f1 score value. Okay, for this particular class, which means basically we just find out the f1 score value by using the harmonic mean, okay, of the precision and the recall. Okay, and how to calculate the harmonic mean? Simply 1 divided by 1 by our observation and divided by the length of the observation. Okay, so this is how you can simply find out the, you can say that the f1 score. So see, here we just find out. Okay, let's find out the f1 score for the class 0. Okay, so first here you have to use the this term. Okay, now basically, like, let me just show you how to find out the f1 score here, then you will understand. Okay, f1 score, this is the 1 divided by 1 divided by the precision value. Okay, for our class, any class, may either class 0 and the class 1. Okay, then the 1 divided by our recall value, because here we have only two values, precision and recall, so you can simply add this two. Okay, so now you can just add this 2 here. Okay, above. Now 2 divided by 1 divided by this thing. Okay, so see, after this, okay, Now we have this thing. Okay, so you can just simplify the formula of the f1, which is the harmonic mean. This is r plus p divided by rp. Okay, so you just take this part, okay, over here. So finally we got the answer as rp divided by r plus p. So this is a formula for calculating the f1 score, and this is a formula for calculating the harmonic mean. Okay, so see here, we are just using this formula, okay, to find out the f1 square. Okay, so see, 2 multiply by our, recall the precision value, which is nothing but this thing, okay, this value. Then we'll just multiply this value, okay, and finally we are dividing this value by r underscore 0 plus p underscore 0. Okay, and here you can see that again round f1 score for class 0, and I'm rounding this value by 2 decimals only. Okay, so this is the formula. Okay, so let's run this and see, we got the output as a 0.95, which is same as this value. Okay, so simply you can say that. Okay, now we just find out the f1 score value. So basically f1 score value, okay, instead of going with these two evaluation matrix, precision recall, separately or the individually, you can simply go and check the f1 score. Okay, if the f1 score is very much close to 1, so you can say that the model is good. Okay, for that model is able to predict that particular class. Okay, see here, we got the f1 score value as a 0.95 for this particular class 0 and the 0.92 for this particular class 1. So you can simply say that your model is quite like significant for making the predictions, okay, for the respective classes, either class 1 or the class 0. Okay, and as well as you can make your like assumptions about the model, whether model is good or not, by using accuracy as well. Okay, but you have to check first precision recall f1 score value. Now, okay, I'm giving you one task, okay, which is a very simple task. Okay, just find out the precision recall and f1 score value, okay, for the class 1. Okay, see, by using these formulas. Okay, so for finding the precision value, simply use the true negative divided by true negative plus false negative. Here, for finding out the formula for like for calculating the recall value, you just use the true negative divided by true negative plus the false positive. And at the time of calculating the f1 score, then you have to use a harmonic mean for of this precision and recall. Okay, now you see, okay, I took like 10 to 15 minutes, okay, to show you just interpretation of this only. Okay, because this is having a like, this is a very high weightage topic. Okay, and it's very important because many a time, okay, you can create the model within a seconds. Okay, you have your systems, okay, which is quite updated one. Okay, and then you can simply just by coding you can simply find out the like model. But which model is good? Okay, for finding out that particular good model, you have to check these things. Okay, you have to check, you have to look at the confusion matrix, you have to check the precision recall f1 score accuracy values. That's why. Okay, so after this session, try to find out the precision recall f1 score value for this class 1, guys. Okay, then so basically this is a confusion matrix and the classification report for the training data. Okay, now let's go use that particular model and make the prediction for the new data, or you can say that the test data. So let's run this. Okay, so see here. Okay, after making the predictions by using the test data, let's see how the predictions looks like. So see, in the test data we have total 100 values. Okay, so that's why here we got the 100 predicted values. And see, this is how our original data look like. Okay, this is nothing but the y data, because okay, at the end we need to compare these two things, predicted values and the actual values. Okay, then only we'll get the confusion matrix and the classification report. So see, now we can simply just compare, okay, manually here as well. So see, first value is first actual value is from the class 0 predicted as a class 0, second is class 0 predicted as a class 0, third one is also class 0 predicted as a class 0. Okay, like this. Okay, here you will see that this, okay, actual value for this particular uh, uh, this, okay, this data point is from the class 0, but here predicted as a class 1. So this is one misclassification. Okay, now see, after that, okay, here we have class 1 prediction, but here we have the class 0. Okay, so you see the difference means some values are just showing you the correct prediction, some are not. Okay, so now we are just comparing this thing, okay, by using the confusion matrix and the classification report. So let's import confusion matrix by using the sklearn, okay, dot matrices, and just use that one to just compare actual and the predicted value of the test data set. And here you see the confusion matrix. Okay, now this is a confusion matrix. Okay, this is in a array format, which means a matrix format. And see, the order of this confusion matrix is 2 cross 2. Why? Because here we are solving the problem of binary class classification. Okay, binary class classification means we have only two classes, either 0 or 1. Okay, so this means this is a binary class classification problem. Okay, if you have 0 1 2, so that is a problem of tertiary class classification, or you can say that this is a that is a problem of multi-class classification. Okay, okay, at that time you will get the confusion matrix, okay, in the 3 cross 3 order. Okay, so see, again, this is a true negative value. Okay, means simply, again, let's go here and try to use this same confusion matrix. Okay, which is 5993. Okay, again 5993, this is for the test. Okay, test data, guys. And here see the 29 value. So total here, the like sum of this all the entries is nothing but 100, because in the test data we have total 100 data points. Okay, this is the true negative value, 59 is the true negative value. Okay, means actually this 59 data points are from the class 0 and predicted as a class 0. Now here we have the 9 value, this is a false positive value. You can say that actually these data points are from the class 0 but predicted that is a class 1. Now we have the 3 value, this is a false negative value. Okay, you can say that actual data points are belongs to class 1 but predicted as a class 0. Then you have the 29 value, which is a true positive value. You can say that actual data points are belongs to class 1 and predicted as a class 1. Okay, so this is how you can just make the like you can just compare your data points, okay, of you can say that predicted values and the actual values. Now, okay, here now we have to just find out the classification report. Okay, now again in the classification report we are just finding out the accuracy, precision, recall. Okay, so see, this is our classification report. Okay, so basically here, okay, we got the accuracy as 88%, okay, on 100 data point. See, for class 0 here, f1 score value, okay, you can just go ahead with this F1 score value instead of this precision recall if you have the F1 score only. Okay, then only. So see, F1 score value is 0.91, which is, you can say that according to me it's good. Okay, greater than 9.9, you can say that good one. Then we have the F1 score value corresponding to class 1, which is 0.83. So you can say that now it's little bit decrease, because here you see the accuracy for the train is 94%. Okay, and accuracy for test is 88%. So this is again little bit decrease. Okay, at that time, okay, for the training data set, F1 score is 0.95 for class 0, F1 score for class 1 is 0.92. So here you will see the decrement, okay, in both the F1 score value, because here we use our model on the new data set. So that's why here we got the accuracy, okay, which is a bit less. Okay, so I can say that this accuracy is also good one. Okay, because 88% is quite good. Okay, but we can improve the accuracy of the model, okay, by taking the different values of k, okay, into account. So I may go with this any value. Let's see here, I may go with 11 value. Okay, let's run this again. Okay, and let's make the predictions on the train data set and find out the confusion matrix and the classification report for the train data set. Now here we got the 92% accuracy. Okay, now let's make the prediction on the test data set as well as after that just find out the confusion matrix. Okay, so after finding out the confusion matrix, here you can see that this is how the confusion matrix looks like. Okay, see, this is a confusion matrix. Now you see the testing accuracy is not changed. Okay, because we here training accuracy is changed, okay, from 94. Okay, it just decreased to 92. Okay, in the training data set, but for the testing data set here we got the same accuracy. Okay, because of, you see, if I change this k value, okay, then I'll get the different accuracy for the training as well as the testing data set. So for that purpose, here I will take the nk values, okay, from 3 to any point of time, like let's say 30 or 50, and I'll try to create the model for each k value, like k equal to 3, k equal to 5, k equal to 7, like that. And after finding the model for each and every k value, okay, I'm going to just find out which k value is the best value for our data. Okay, so for that purpose, here we have to find out the plot, okay, which will be just plotted, okay, in the upcoming data set, okay, in the next data set. Okay, so see, here you will see that we are just making the visualization, okay, for our model, which is nothing but the KNN model, and here we are making the visualization on the training data set. Okay, so basically here I am creating the like I'm plotting all the data points x train and y train, and see, here I'm also just mentioning the estimated data points. Okay, see, here I'm estimating the data points, means I'm predicting the data points, and after that I'm just splitting those data points into different colors, red and green colors. Okay, so see, let's run this and you will see the very good plot of classification. Okay, Okay, done. So see here, we just use k nearest neighbor on the training data set and see this is the model. Okay, so you see this curve or line, this is the line for classification. You say that this is the classification model of the k nearest neighbor. Now you see here we have two regions, okay, green region and the red region. Okay, so few data points, okay, you can say that in the red region we have most of the data points are nothing but the red data points, okay, red color data points in the red region. So you can say that these data points are nothing but the correct negative data points, or you can say that these are the true negative data points. Now you see the in the red region itself we have few green data points. Now these green data points are nothing but the misclassification, okay, incorrect classification, because here you see these data points are in now red region, okay, but these are the green data points. And okay, those, this green data point should be in the green region, okay, but model predicts as a they this these data points in the red region. So you can say that this is the incorrect classification. So this value is nothing but the false negative value, means model predicts as this data points are the negative data points, but actually this green data points are the positive data points. So that's why you can say that here this is misclassification. Okay, now see the green region. So in the green region we have most of the data points are in the green color. So you can say that this is nothing but the correct prediction for class 1 or for class or for positive class. Okay, and see here in the green region we have few red data points, which means these red data points in the green region is nothing but the incorrect classification or the misclassification. Okay, so now here you can see that this is how we can create the model of the k nearest neighbor, and you can draw the model like this. Now let's go and again draw the same plot for the testing data set. Okay, here we build the model on the training data set, and we again here also we just make the prediction. Okay, now let's go and find out the prediction on the new data point. Okay, so see, for that purpose I created the model classification plot for the test data set. Now see, now this is a red region. Okay, now most of the data points in the red region are those are black. You can say that those black point in the red region is nothing but the correct prediction. Okay, or you can say that this is the true negative. The white data point in the green region is nothing but the true positive. Okay, and few data points those are black in the green region, you can say that this is nothing but the false positive. Okay, because model predict as those black point in the green region as a positive data point, but actually they are negative data point. Okay, and few data points which are white but in the green region, you can say that this data point is nothing but the false negative data point. Okay, model predicts as these data points are the negative. Okay, but actually they are from the positive class. Okay, so that is how you can make the classification of each and every data set. Okay, so before going to this, okay, second data, okay, we'll take a small break. Okay, importing the pandas library as well as the numpy library. And as we know, okay, we are using pandas library for the data wrangling or the data analysis, you can simply say that, and okay, in python, and to read the data set. Then we can use the numpy library for creating the n-dimensional array as well. well as some statistical analysis. Okay, so let's go. Before that, let's clear the output first. Okay, and see here, let's run the first run this cell for importing the library, and after this let's read the data, which is iris data set. And you can see the data set by using the iris dot this head method. Okay, so let's run this and see, this is our data. Okay, you can see the top 5 entries of the iris data set. Basically iris is a flower in, and this is a flower, iris flower with different species. Okay, here basically we have three main species of iris flower. First one is the setosa, second one is the versicolor, and the virginica. Okay, like this. So you see here, okay, we have the species of the setosa. Okay, so you can say that this is one class. Okay, because okay, we have the sepal length, okay, of the iris flower, we have the sepal width, we have the petal length, as well as we have the petal width of the iris flower. And here you can see that, okay, you can see that we have another column which is nothing but the species column. You can say that this column is a target column or the output column. Means we are using the these 4 columns to build the model. Okay, means this is the input data points. Okay, and by using this as well, we are like by using this combining 5 columns, we are using this to build the model. Okay, and for that purpose we have to first split the data into training and testing data set. Okay, so see here, we are just splitting the data of iris into testing into train and the test data set. And see, the test size is nothing but the 0.2, which means this is a like I want the 20% of overall data, okay, in the test data, and remaining 80% of data into the train data. Okay, so that is my splitting criteria. And this is the random state parameter. Okay, why I use this random state parameter here? Because you see, I'm splitting this data, okay, by using train and test split. Now this train and test split gives me a split in a random manner. Okay, so if I use this particular random state parameter with this particular value, or you can use any value, okay, it's totally random. You can even use 2 value, you can even use 5 value or 8 value, any value. Okay, I use, let's say, 28 value. Okay, so if I use this any random value, and I now I want to use this train and test data, okay, for creating the multiple model. So you see, now I am getting the train and test data, okay, for each and every time. Whenever I'm running this particular cell, at that time I'm getting the same data set into training and the testing data set. So which means, okay, I'm just building the model with the same data set. Okay, and again, okay, and I got the model, okay, or I got the data set as a train and test, okay, by using the random sampling as well. Okay, so this is the advantage of this random state parameter. Okay, so let's go and run this, and you see again, now we are using sklearn dot neighbors. Okay, from here we are importing the knn, means the k neighbors classifier, okay, for building the classification model as the knc. Okay, many time you see this is a big word. Okay, by combining 3 different words. Okay, so I'm just using, okay, I just store this, you can say that I'm just store this particular classifier as the KNC. Okay, now instead of this big word, I can simply use this. Okay, so let's go and run this particular cell. And now see here, now I am using KNC, and here I am mentioning the n neighbors parameter equal to 3, means here I am going with k value equal to 3. Okay, so let's go and create the model first, and then after creating the model, let's go and fit the model, which is a k neighbors classifier model, on our train data. So you see, this is my train data. Okay, this is my, in the train data we have input data. Okay, this is the input data, first full column. This is the output data, last one column. See, this is the first column, first four column are nothing but the input column, and last column is the output column. Okay, so that's why I use this iloc command, okay, to extract the particular columns, okay, from the train data, which is iloc means the index location. Okay, and see here, with the help of this np.mean, see, I'm just finding out the mean by using the numpy library. Okay, so see here, I'm making the predictions on the train data itself first, and then I'm comparing those predicted values by original data points. Okay, and after that, let's see the training accuracy. Okay, so let's run this. See, this is the training accuracy. Now you can simply round this training accuracy. Now the training accuracy is 96%. Okay, now after that, for finding out the confusion matrix and the classification report, you have to store your predicted values, okay, into some name. Okay, with some name. So see here, you can say that this is a one variable as well. So after storing the predicted values as a y train predict, okay, see here I'm using again sklearn library dot matrix, and from this I am importing confusion matrix and the classification report, and by comparing actual value in the train data set, which is outcome or target values, and the training predicted values. So here I am just building the confusion matrix and the classification report. So let's run this and see. Now you see the order of this matrix. This is a matrix of order 3 cross 3, because here we have three different classes: Setosa class, we have versicolor class, we have Virginica class. Okay, see, now this is a problem of multi-class classification. Okay, so you can say that these diagonal values are nothing but the correct prediction now. Okay, instead of true positive, true negative, false positive, and the false negative, you can simply say that diagonal value means correct prediction, and non-diagonal values of the confusion matrix in the is nothing but the incorrect prediction. So you see that here in the first column as well as the first row, only diagonal value is the positive, and the remaining entries are 0, which means this Setosa class, okay, here you will see the 100% prediction for the Setosa class only. Okay, and then you can see that for versicolor class, okay, correct prediction is 37. Okay, two are incorrect prediction. Okay, for virginica class, correct prediction is again 37, incorrect prediction is 3. See, so this is a problem, means there are only 5 misclassification. 2 plus 3 is nothing but the 5. You can say that they, okay, model predicts that only 5 data points, okay, as a incorrect classification. So see, accuracy is 96%. In the training data set, you have the 120 data points. Basically, in the data set, okay, see here, in the testing data set, you use only 20% of entire data set, okay, in the testing data set, okay. Overall data set, in the data set, we have the, you can say this, okay, let me find the shape, okay, and see the shape. Now the shape of the data is 150 and 5, which means we have here 150 data points and the 5 columns, okay. So only 20% of these data points in the training data set, which means only 30 data points in the testing data set, and remaining 120 data points in the training data set. So see, 120 data points in the training data set and remaining 30 data points in the testing data set. Now you can see that here the F1 score value, okay, for Setosa is 1, for F1 for versicolor is 0.94, for Virginica is also 0.94, okay. And you see some like all the precision recall F1 score value which is greater than zero point 0.9. So you can see that this is a quite good model, okay. And see number of data points, okay, from each class. Now let's make the prediction for the test data set. Now as we know, in the test data set we have total 30 data points, okay. So see, the accuracy for the test data set is nothing but the 0.9666. You can say that approximately 97%. So let's run this and see the oh sorry, it's quite good. Okay, see the accuracy, which is nothing but 0.97, which is a 97%, okay. And now you can store your predictions on the test data set, and you just create the confusion matrix and the classification report, okay, by comparing your predicted values and the actual values in the test data set. So see again, here also I got the, you can say that confusion matrix of order 3 cross 3, okay, for each and every class, Setosa, versicolor and Virginica. Now you see that here for Setosa class, okay, in the test data set as well, I got the 100% prediction, which is correct, okay. For Virginica class, for versicolor class, I got here one incorrect prediction, one extra prediction here, okay. And see, this is the, you can say that again, here we do not have incorrect prediction, but here we have one incorrect prediction. That's why the precision for versicolor Virginica class is 0.91, as well as recall for versicolor is 0.91 because of this one incorrect prediction, okay. And you see all the diagonal values are positive, and only one non-diagonal value is positive, which is 1. Means here in the test data set only one prediction which is incorrect, okay. Now you can change the value of k and again go with the same step. After that, after building the model, let's fit the model, and after that let's find out the training accuracy and the testing accuracy. See, the training accuracy is 97%, as well as the testing accuracy is also 97 for the value of k equal to 5, okay. So here you can see that here you got the training accuracy as a 96%, but the testing accuracy is a 97%, okay. But here we got both training and testing accuracy as a 97%. Now let's use another any random k value, okay, and find out the training accuracy and the testing accuracy. Now you see the training and testing accuracy. See, for k equal to 15, training accuracy is 0.975 and testing accuracy is a 97%. Now Now you see for each and every k value, okay, we are getting, okay, I'm getting different accuracy for training and testing. Now let's build the model for k equal to 3, k equal to 5, up to k equal to 49. So here, see, first I'm creating accuracy, and this is a empty list, okay, for storing the all the accuracies in terms of training data set as well as the testing data set. Here I'm creating the for loop with the range method. See, this is the lower minimum value, maximum value, and this is the splitting criteria, okay. This is the three. Now they, after that, by just difference to this 3, 5, 7 like this, okay, I'm getting the value for this I, okay, and in the last, okay, I'll get the 49 value, okay, because you see the difference from, if you take the difference, okay, of 2 from 3, then you will get the last value as a 49. Then here I'm creating the classification model, or the by using the k neighbors classifier, okay, for each and every k value. See here, I just mentioned the ki value here, because now I'm starting with 3, 5, 7 like this. So here I'm just adding each and every I value here. Now again, on each and every model, okay, for each and every model I'm fitting that particular model on our training data. Now then I'm finding out the testing accuracy, sorry, training accuracy, and then testing accuracy, and you see at the last I'm appending this training and testing accuracy in this accuracy empty list, okay. So let's go and run this. Now you see, I just build the multiple models of k nearest neighbor. Now I'm using this accuracy, okay, to find out the training testing plot, okay, accuracy plot of training data set as well as the testing data set. So see, now for some k value, so you see the red, this line, okay, is for the test, okay, then this blue line is for the train. So you see, if I take the k equal to 3 here, I got the value for the accuracy of the training data set is about 96%. Any questions? Okay. So see, for k equal to 3, training accuracy is 96%. Here testing accuracy is a bit high, which is 97%. Then for k equal to 5, you see, training and testing accuracy is 97% approximately, because see here, for k equal to 5, training accuracy is 97% approximately, as well as the testing accuracy. So here this is the k equal to 5 value. For k equal to 7, okay, test testing accuracy is 97%, and the training accuracy is quite big. You can say that this is 98% approximately, okay. Now see the difference. Now here we got the training accuracy as 100%, okay. Now first we have 3, 5, 7, and 9. So for k equal to 9, here I got the 100% accuracy for the testing data set, and 97% accuracy for the training data set, okay. So again, you can say that this model is good, but see here, if you are using the training and testing data set for comparing the model, then the difference between the accuracy of the training and testing data set should be minimum, okay. But you see the difference is here is quite minimum, but not that much, okay, not this much. You see, for k equal to 11, as well as for k equal to 13, k equal to 15, k equal to 17, k equal to 19, okay, these all are giving you the test accuracy as a 97% and the training accuracy as a 98%, okay. So you can simply go ahead with this k value or even this k value. Okay, this is a k equal to 7. Okay, so simply just use a k equal to 7 here instead of 5. Okay, or you can just go ahead with k equal to 11, because the training and testing accuracy, now you can see the slightly very much lower, you can see the difference between training and testing accuracy is minimum. Okay, as compared to this k equal to 9. Okay, so you can go ahead with this. Many time, see, this is the test data, means you can say that this is a new data for the model. Okay, so you see this is the 100% accuracy for the test data. Okay, so you can say that, sir, go with this k equal to 9 value. Okay, but here if you change your test data, okay, okay, as you are getting the new data points, okay, after some time, and then okay, then you have to apply your model on that new data, na? So at that time you may get some different values, okay, of the like in terms of accuracy for your new data set. Okay, so that's why here we got the training accuracy which is highest. Okay, for k equal to 7, k equal to 11, k equal to 13, like this. Okay, so you can choose any k value in between this, like k equal to 7, then 9, 11, 13, 15 or 17. Okay, then definitely your model is quite good. Okay, or you can just go with this k equal to 17 as well. Okay, to get the better model, as a k value is high, then you can try to like find out the highest, you can say that neighbor values, na? So at that time you can just make your classification in a better way. Okay, this is how you can make the classification. Okay, or this is how you can build your classification model by using the k nearest neighbor. Okay, now basically this is one of the simplest method in machine learning. Okay, and I hope you guys all just understood this all the thing. Okay, now let's go, and after that let's go and see the unsupervised learning, which is a classification clustering part. Okay, so let's see here. Okay, okay. Okay, see here. Okay, so let's go with the clustering analysis now. So basically, as we know, after completion of this supervised learning part, okay, let's talk about the unsupervised learning. And in the unsupervised learning, as we know, there are a lot of algorithm like clustering, like principal component means a dimensionality reduction algorithm, then we have the association rule. Okay, like this we have different algorithms or the types of unsupervised learning. And basically here in the unsupervised learning we are dealing with the, you can say that here we are dealing with the only input data set. Okay, means in our data we have only input data set. So basically it is a data mining technique which groups the data based on their similarities or differences. Okay, then clustering algorithms are used to process raw unclassified data objects into groups represented by structures or patterns in the information. Okay, so the clustering algorithms can be categorized into a few types. Okay, especially you can say that hierarchical clustering and the non-hierarchical clustering, and we also have the probabilistic approach for this clustering. Okay, so in this boot camp, we'll be talking about the hierarchical clustering only, because here in the hierarchical clustering, see, we have different types of linkage method. Okay, Okay, so basically we have so many different types of linkage method. Okay, and these are the few important linkage method. Okay, and here in the hierarchical clustering we can make the data visualization plot, which is nothing but the dendrogram. Okay, so from the dendrogram you can visualize your clustering. Okay, means you can just find out the how many clusters you want, how many groups you want to create, okay, from your data set, okay, by using the dendrogram. So this is first one is the complete linkage method. So basically you are using maximum distance, okay, to find out the or to split the data, okay, into the different clusters. Then we have the single linkage. Here we are using the minimum distance between 2 points, okay, to find out the cluster. Then we have average linkage method. Here in this method basically we are using the mean distance or the average data points, average of data points, okay, to find out the clusters. And in the Wand's linkage especially we are using the sum of squared, okay, to find out the clusters. Okay, so this is how, this is a graphical representation of the linkage method. See, first we have the simple linkage, oh sorry, it's a single linkage, then we have the complete linkage, and we have the average linkage. Okay, so see, here in our data there are two groups. Okay, so how to find that particular data point is lies in particular group, okay, and how to split our data set, okay, into two different clusters. Okay, so for that purpose we have different linkage methods. So see, in the single linkage basically we are finding out the clusters, okay, by using the minimum distance, okay, minimum distance data point. Okay, see, then in the complete linkage we are finding out the maximum data, maximum distant data points, and with that we can simply find out the, we can just split our data set into different clusters. And in the average linkage simply we are using average of data points to find out the different clusters. Okay, and as we know, this is how we can apply the clustering analysis on the our data set. Okay, so now let's go and before that before going into the coding part, let's go and see one example how to use or how to implement single linkage on our data set. Okay, so before that, okay, so that's why we are using this single linkage method to show you how we are applying this, okay, single linkage. Okay, so see, here basically we have the single linkage clustering here. Okay, so suppose we have the different data points in our data set, and we are finding out the minimum distance data points, and from that we are just splitting our data set, and in the last we just find out the clustering. Okay, so you can here see that here this is my data points, or this is my database. Okay, x and y, we have the like data set in the 2 dimension. Okay, so I can make the plot of it, and I means I can create the scatter plot of x and y axis, and I can use the different points. Okay, p1, p2, p3, p4, 5. Okay, and then 6. So total we have the 6 data points. Okay, so now I have to check that, okay, how many clusters I can create, okay, to split this data set. So see, now I can simply just plot this data set, okay, by using the scatter plot. So this is our data set look like. Okay, these are my points 1 2 3 4 5 6. Okay, this is a simple example, is to just my intention here to just show you how to implement single linkage cluster on the our different data set. Okay, so see, in the second step we are simply calculating the distance by using the Euclidean distance or any different distance matrices. Okay, which is nothing but the Minkowski or Manhattan distance. We have so many as well, like in the form of like triangular distribution. Okay, so see here, this is a Euclidean distance for the p dimensional. Okay, see, xp. Okay, so which is nothing but here I am finding the distance between two data points in the p dimension. Okay, so see, here I am using the like x1 minus x2 square, so that's why you can just use the parenthesis or the modulus. It's both are same here because I used here square term na. So then see, for finding out the distance between 2 points, okay, you can simply use this x1 minus x2 y1 minus y2. Okay, so simply just find out this all the calculations, and here finally I got the, okay, the value of the like distance between 2 points. So see, here total we have 6 data points. Okay, so after finding the distance between these 6 data points, means the distance between each and every data points. Okay, so see here I got the matrix, which is a distance matrix of order 6 cross 6. Okay, so if, okay, so you can just use a lower triangular or the upper triangle, okay, of the matrix, which is a distance matrix, because this is a symmetric matrix. Okay, you know what the symmetric matrix is. Okay, means both this lower side, means the lower triangle of the matrix, and the upper triangle of the matrix is same. Okay, so this is nothing but the symmetric matrix. So see, as we know, the distance between me and myself is 0. Okay, because there is no distance now, so that's why the distance between the point with itself is 0. Okay, so that's why all the diagonal entries, okay, are showing you the 0 value. Okay, now you see, I just find out the distance between p1 and p2. Okay, here over here. Okay, distance between p1 and p2, and by rounding out this I got the 0.24 value. Okay, in the same way I found out that all the distances between each and every point, distance between p1 to P2, then P1 to P3, P1 to P4, P1 to P5. Okay, in the same way, I just found out all the distances P5 to P6. Okay, and then after that, here from these differences, all the distances, you see here I am implementing single linkage clustering. Okay, so single linkage clustering means here I want to find that minimum distance points. Okay, so that's why out of all of these points, which 2 points distance showing a minimum value. So here minimum value for this minimum value is 0.11. Okay, which is for zero point 0.3 and zero point 0.6. So in simple word, we are going to merge these 2 points, and here we just create one cluster. Okay, so see, I'm just created one. Okay, I just created one cluster here. Okay, by merging this 2.3 data point and the zero point 0.6, means the 3 and 6 data point. So see, and side by side I am creating dendrogram. Okay, now like at the end of this clustering part, this single linkage example, you will understand how like the dendrogram, like how to create the dendrogram and why it is so important in the hierarchical clustering. Okay, and as well as we'll create the dendrogram in the coding part as well. Okay, and see, basically first in the first step, means in the first time, we just merge these two data points, which is zero point 0.3 and zero point 0.6, and see I just by distance this 0.11, so somewhere like somewhere above here. Okay, so I just use this green color, okay, to locate the distance for this first cluster, which is a point 0.3 and point 0.6. Okay, understood? Then after that, here I just want to again find out the distance between, again by like just repeating the distance between each and every data point. So see here, now I just merge these two data points. Okay, now we got here the one cluster. Okay, now how to find the distance between this cluster? This is now one cluster, not the 2 point, guys. This is one cluster. Okay, now how to find the distance between this cluster and these points? Okay, p1, p2, p4 and p5. Okay, so for that, here I just add this method here. Okay, so see, first I know the distance between p3 and p1. Okay, from here I can find out the distance between p3 and p1. Okay, so this here you can see that this is the distance between p3 and p1. Okay, which is 0.22. Then after that, what is the distance between P6 and P1? So here you see the distance between P6 and P1 data point, which is 0.23. So I use these two distances, okay, and I just put these distances here. And here I'm finding out the minimum distance between these two data points. Okay, so minimum distance is 0.22. You can say that the distance between this cluster and this point is 0.22. Okay, see, it is very much simple. Okay, so I just add this 0.22 here. In the same way, I found out all the distances which are new. Okay, so means I have to calculate the four distances. Okay, this four. Okay, the p means this cluster to p1, this cluster to p2. Okay, like this cluster to p4, this cluster to p5 distances. So now all these remaining distances are okay, are the same as the original. Okay, as in the original matrix. So see, this is same, this is same, and this is also same. Okay, so see, you can just cross check. Okay, after the session I just updated these four distances only. Okay, now here you can see that now this is my updated distance matrix. Now in that distance matrix, now this is a second iteration. Now I reduce this distance matrix from 6 cross 6, okay, order to 5 cross 5 order. See, now the matrix order of this distance matrix is 5 cross 5. Okay, now here I'm finding out the minimum distance, and the minimum distance is 0.14, which is between this point 0.5 and point 0.2. Okay, now I'm merging these two cluster, okay, these 2 points as a cluster. See, this point 0.5 and the point 0.2. So I merge these 2 points in a one cluster. Now here at the distant 0.11, I got these 2 points as a one cluster. At the distance point 0.14, okay, I merge these two data points, point 0.2 and point 0.5. See, now this is the dendrogram. Okay, in the second iteration. Now again I'm using the same formula for finding out the distance between this. Okay, now we have the two clusters now, guys, and this is a new one. Okay, this is a new cluster now for this distance matrix. So now I have to find that these many values only. Okay, and this all the values 0.22, 0.37, 0.15 is already there in the previous distance matrix. Okay, so again by using the same formula, see, now here as we know how to find the distance between cluster and the point. Okay, distance between the cluster and the point. Here you can see that here we just found out the distance between cluster and the point. Now here our main problem is to find out the distance between the, you can say that, the two clusters. Okay, distance between the two clusters, this is our main problem here. Okay, so basically same in the same way we are using the, you can see that we are using the both clusters. Okay, this is my one cluster and this is my another cluster. Okay, so see, I'm using the minimum distance between these 4 points. Okay, I know the distance between these 4 points, okay, in my original distance matrix, in my initial distance matrix. Okay, so see, I just found out the distance between P3 and P2, P6 and P2, P3 and P5 and P6 and P5. Okay, this much. Okay, you can find out this distance values, okay, from original distance matrix. Okay, so see, minimum distance is 15, so you can simply add this term 0.15 or 0.15 here. Okay, understood? So like that, wait guys. Okay, so see here, now the distance between these two cluster is minimum. Okay, as well as the distance between these two this point 0.4 and this one cluster is minimum. Okay, so now in that case you can go with any point. Okay, either this distance or either this distance, but okay, according to me, merge the two clusters first. Okay, because in the clusters we have multiple data points. Now here we have two data point, here we have two data points. So basically from here, okay, from this step we are merging four data points in a one cluster. Okay, by this distance. So that's why, see here, we just merge the these two clusters, okay, by the distance 0.15. Okay, understood? After that, again, by doing the same steps, let's calculate the distance matrix in reduced order. Now here the distance order of this distance matrix is only 3 cross 3. Okay, why? Because see here we just merge 4 points and total we have 6 points only. Okay, now in the same way as we find out the distance, okay, between the cluster and the point, between the cluster and the cluster, by using the above formulas you can simply find out, okay, the distance between this, okay, this cluster and the point. Now here we have to, here the formula is very much simple. Okay, the minimum distance between this p1 and p2, p1 and p5, p1 and p3 and p1 and p6 means you have to find out the four distances, okay, from the original matrix. And out of these four distances you have to check which gives you a minimum distance. So here minimum is 0.22, so you can simply go ahead with this 0.22. Okay, and in the same way you can just find out the distance between the point 0.4 and this cluster. So see here, now your, okay, minimum value in this distance matrix is 0.15. Now you are merging this p4 into the cluster. So see, at the distance 0.15 you just merge your new data points into the cluster. Okay, so at the last, okay, you see that now your order of the distance matrix is only 2 cross 2, means you have only one value in your distance matrix as a distance between the cluster and the point. Okay, now you can merge that one point into the cluster, okay, at the last. So now simply you can see that this is my dendrogram. Okay, now from this can you suggest me how many number of clusters I want to create? Okay, so basically here I use the minimum distance, means the single linkage clustering, okay, to find out this, okay, the different clusters. So basically I can create the 6 clusters, okay, by cutting this dendrogram from here, okay, which means in each clusters, okay, I'll get one data point. If I cut the this dendrogram from here, then I'll get the 5 clusters, okay. In one cluster here we have 2 data points, okay, and then in the remaining clusters we have only one data point. If I cut my dendrogram from here, so you can simply say that, okay, from here, so you can simply say that now you have these clusters as well as you have these clusters, means in 2 clusters you have two data points, and in remaining 2 clusters you have one data points, okay. So likewise it's up to you, okay, how many clusters you want to create from, okay, by looking at just dendrogram, okay. Or basically this is a single linkage dendrogram, so that's why it looks like this. If you use the complete linkage, so at that time instead of using this minimum distance formula, here in the complete linkage, okay, we are gonna use maximum distance between the 2 points, okay. See here, we use a maximum distance in the complete linkage na? Okay, so many time complete linkage gives you a very standard dendrogram, okay. We'll see in the coding part, okay. So understood this calculations, how we just implementing the single linkage clustering on our data. You can even implement the multiple complete linkage clustering as well as average linkage, Watts linkage, as well as median linkage, weighted linkage, okay. This many clustering linkage you have, okay. Just change this formula, okay. If you are using single, you just use minimum. If you are using the complete, you just use maximum. If you are using the average, just find out the mean, okay. If you are using the watts, just find out the sum of square, okay. So now after this, let's go and just do some coding, okay, for the, you can say that, for the clustering part, okay. So here you can see that, so any questions related to this, okay, the theoretical part of it. So if you have any questions, so you can like just ask me, so I can just solve your dot, okay. So let's go and clear all the outputs, okay, and see now. Basically here we are just using the university's data set, okay. So basically we are just creating the clusters of the different universities, okay. So basically let's say like you want like you wanted to get the admission of one of these universities. You have the list of universities and you don't know which university is best for you, okay, as compared to your expenses, okay, your family background, your like financial background, okay, like overall this, your score, okay, your graduation score, okay, like all of this. So for that purpose, okay, we have to use a clustering analysis, okay. We have to apply clustering analysis on this data set, okay. And then after that we can just classify this university's data into the different clusters, and then you can then after that you can say that like which university is good for yourself, okay. So see, first I'm importing the pandas and matplotlib library, and see after that I'm reading my data, which is nothing but the university's data, and this is how our data looks like. Basically, we have the different university. Okay, so see, I can just run total data. See, this is my data set. Okay, so basically in my data set I have 24 universities. Okay, see, I have the Dartmouth University, Cornell University, I have Duke University, then Harvard University, MIT, then Penn State. Okay, then I have Stanford, then U Michigan. Okay, then Yale's. Okay, so these many universities I have. Okay, so this is a different criterias, okay, for accepting the like candidacy for the different universities. Okay, like the SAT scores would be like for this particular Brown University. Okay, SAT score would be 1310. Okay, like this, you have the SAT score, you have the top 10, you have the accepted. Okay, like number of students they are accepting. Okay, then SF ratio, then you have expenses, and then you have graduation rate. Okay, so see, this is your data, and you have to create the like the like 2 3 universities which are suitable for you. Okay, or even like if like someone is dean or the vice chancellor of the university, so that person can always can use this analysis for finding out like the university of that person in which tier. Okay, like tier 1 university, tier 2's university, or the tier 3's university. So then the like which universities are nothing but the the competence. Okay, so see here, first in the clustering analysis, when you are just applying the clustering analysis on your data, first step is to transform your data, because you see the different ranges of the data. Okay, see, this is top 10, you have the two digits, yeah, data point, then you have accepted, accept. Okay, then you have the SF ratio, then you have expenses. You see the expenses is in the 5 digits, so you see the range, different range for different columns. Okay, so it is very good to apply some data transformation, whether it is a minimum max scaler or this scale standard scaler. Okay, so you can simply use this transformation, or simply apply this transformation on your data, so then you will get the all the columns in a one range. So simply here I am creating the normal function, which is a normalization, which is same as the standard scalar. Okay, here my intention is to show you, instead of using sklearn library, you can apply data transformation by using in Python. Okay, sorry. So see here. Okay, here I created one function by using this def. Okay, so I created norm function, and here I'm just adding each and every data point. Okay, and after finding out the mean and the standard deviation, simply this is the central limit theorem formula, and finally here I'll get the all the values. Okay, so see, I'm applying this norm function which I created here, so on my university data set from index 1 column to the end. Okay, so see, I'm implementing this standard scalar method, data transformation method, on this many, you can say that this many columns. Okay, so let's go and run this particular cell. So see, after applying normal scale, okay, you see we just transform the range of the columns, okay, which are numeric, because these are the university name only. Okay, which is not important. Okay, this is important for comparing the university. Okay, after finding out the clusters. So see here, this is how we just transform the range of our columns. Okay, after transforming this, now each column has a like each and every column in the data set having a same weightage, okay, for just applying the linkage method. Okay, now see here, now I am using the SciPy library. Okay, you see, okay, SciPy library is very much important for, like, we use this for statistical analysis. Okay, and this is a data mining technique, so that's why it's data mining is, you can say that, one of the topic of statistics, advanced statistics. So see, by using SciPy, okay, you are just importing this one module, in that you have another module which is the hierarchy. Okay, and you are importing the linkage method. Okay, and again, by using the same library, scipy.cluster module dot hierarchy module as sch. Okay, basically we are using this module for creating the dendrogram. Okay, so let's run this. And after this, here we are just creating or applying the complete linkage clustering method on our data. Okay, so see here, this is a Z complete, means basically here we are creating the distance matrix. Okay, distance matrix is nothing but this matrix. So see, this is my distance matrix. Okay, this is my distance matrix. Okay, so first, okay, before doing the clustering, okay, I want to create the distance matrix. Okay, so see here, I am just creating the first distance matrix. Okay, see here, this is my df norm, this is my this data df norm data. See, this is the data df norm, this is how the data set looks like. Okay, here I'm using the complete linkage method with distance formula as a Euclidean. Okay, you can say as the metric. Okay, so see, by using by applying one line of command, I created the distance matrix of order 24 cross 24. Okay, actually here we can't see the matrix of 24 cross 21 because the matrix is quite good. Okay, so see, after actually basically, like, if you want the certificate, so like at the end of this session I'll share the one link which is a feedback form. Okay, you have to submit that particular feedback form. Okay, and after submitting the feedback form, you will be getting the certificate for this boot camp. Okay, so at the end of session I'll share that particular link. Okay, so see here, after creating the distance matrix, now I am creating the dendrogram. Okay, now I don't have to just go with each and every step. Okay, for creating the, like, for finding out the, like, how to merge particular point. Okay, in Python. Okay, with the help of just this linkage method. Okay, this, you can say that the hierarchy, I just use this module for creating the dendrogram. Okay, by using this, so see, if I run this particular cell, so you see the dendrogram. Okay, and it's very effective dendrogram. Okay, which is, I created this by using the complete linkage. Okay, see, this is the title and this is how we are just extracting dendrogram. This is, here I am using the Z complete, means this is a distance matrix. Okay, leaf rotation is 0. Okay, means the x-axis rotation, and just font of font size for the x-axis, means the labels on the x-axis. Now see the dendrogram. Now this is very beautiful dendrogram. Okay, we just created by using the complete linkage clustering method. Okay, now can you guys tell me the how many number of clusters we can form, okay, by using this complete linkage? Okay, you can drop the message on the chat box fast, guys. How many number of clusters we can form, okay, by just looking at this particular dendrogram? Anyone, guys? It's very easy. I'm audible, guys, to you? Yes, yeah. It's a like total data points 24. So yes, definitely we can create the 24 clusters. But like here, like one data point is absolutely a one cluster. But like client don't want that much type of like clusters. Means then like why client give the data to us? And the data is very you can say that precious for the client. Okay, so like here the requirement of client is to just find out the clusters like 5 3 7 4 2. Okay, in that manner. Okay, so can you tell me the different like the cluster number in terms of like in the range of 5 to 7? Because see, okay, okay, don't worry, let me like show you how to find the like how to select the number of clusters from the dendrogram. So see here, first, okay, first Python like give you a different number of clusters, okay, by using this different color. See, this is my one colors like plot, and this is my another colors dendrogram. So see, you can split your data into two groups or two clusters. So see, in my first group, okay, we have 15, 17, 2, 20, 13, 23 index numbers data point. In my second data we have this many numbers, okay, this many index numbers data points. Okay, or you can create, okay, or you can split your clustering into three clusters as well. See here, if you split your dendrogram from here, so see, this is little bit uh, big as compared to this. Okay, so you can make the split, okay, of your dendrogram from here. Okay, so now this is your one cluster, this is the another cluster, and this is the another cluster. Means you can create the three different clusters by using this dendrogram, or you can even create the two different clusters. Okay, so I'm going with the three value. Okay, means I'm splitting the clusters into I'm splitting the data into three different clusters. Okay, so here you can see that now I am using the agglomerative clustering. Okay, this is another name for the hierarchical clustering. Okay, okay, in the agglomerative clustering we have the hierarchical clustering, like it's a bottom to up approach, and we have another divisive clustering, this is a up to bottom approach. Okay, so with the help of sklearn now, okay, in that we have the cluster module, and with the help of that, okay, just we are importing agglomerative clustering. Okay, so see, by just importing the agglomerative clustering, I can just use my data, okay, to transform or to split the data into different number of clusters. So here I use the n clusters equal to 3, means I want 3 clusters from my data. Okay, or I want to split my data into 3 groups. Okay, and see here I am using the linkage method, which is complete, and affinity, which is nothing but the distance matrix Euclidean. Okay, so let's go and run this particular cell. So after running this particular cell, see here, okay, now we just find out the labels. Okay, so here you can see that this is my H complete. Okay, this is my clustering model. Okay, and here from the clustering model I'm importing the labels, means the outputs in terms of different clusters. Okay, because I created 3 clusters here, so that's why here my output will be in 3 different classes. Okay, 0 class, 1 class, and 2 class. So see, now you see the data points, okay, with the index number 0 to 24. Okay, and I split it, the data points, into 3 different clusters. Okay, so see here, your index number 0 is here, and this is my 1 cluster. Okay, so let's go and just, you can say that, the store this particular label by using the complete linkage method. Okay, see here, I created one new column, okay, by name complete linkage. Okay, and here I'm storing these labels, means these values, this all the clustering values. Okay, so see, after storing these labels by you on my original data set, so see, again I want this complete linkage column, okay, at the starting of my data. Okay, means this is a column 1, okay, which is a complete linkage, then remaining all the columns in my data set. And this is how I just find out the complete linkage. Okay, so see, this is a complete linkage. Okay, now you can see that here I'm using the pandas library, in that I'm using the group by method. Okay, now basically, why group by? Because see, this is my column, and in that column I have 3 different classes, 2, 1, 0. Okay, so here I'm applying this group by, okay, on this column, okay, to find out the number of data points which belongs to this two class, number of data points which belongs to this class, number of data points which belongs to this particular class. Okay, and see, from this, okay, now you see, this is a, in Python, this is a index 0 column, this is a index 1 column, and this is a index 2 column. Now these all columns are nothing but the, you can say that, the numeric column. Okay, so you can find the mean or median value. Okay, so here I'm going with like I'm using the index 2 column to the end, means all the columns, and I'm applying group by function. Okay, by using this column particular, and I'm finding out the median. Okay, in short, okay, in this particular, means let's say this is the class 2. Okay, I'm finding out all the rows, okay, which is showing this 2 value in the complete linkage. Okay, and I'm finding the median for all this value. Okay, so see here, you can see that now, for corresponding linkage, okay, for correspond, these are my cluster. Okay, not the classes. Okay, this is not the classification problem, this is a clustering problem. Okay, now this is only the label. Okay, this is my cluster 1, or you can even say that this is my cluster 1, or you can even say that this is my cluster 1. Okay, okay, now here I'm using median. Okay, so now you can say that, depending on this much median value, okay, you can simply say that, okay, I want SAT score this, okay, or more than this. Okay, then only, okay, I can get the admission on this particular clusters university. Okay, so like, let me first, okay, go with this. Okay, so before that, let's go and just use this. Okay, so here see, with the help of university dot to underscore csv, and see under university underscore cluster dot csv, means I'm storing my this data, this clustering data, all this data in this university underscore cluster data set. So see now, basically, see, this is a 9:40, and this is the timing. You see the time, okay, the same time. And let's open this file, okay, which is a csv format file. And here I am opening this file. Okay. So see, this is the index value. This is not important. Okay, so let's go and delete this particular part. Okay, and see, this is my data. Okay, now this is my clusters. Okay, now I can just sort this. Okay, see, I just sort out, means I just convert this data, okay, by using this particular uh, thing. Okay, so now let me add few rows here. Okay, for finding out the mean value, okay, for this particular part. So see, this is my one cluster. Okay, in my one clusters I have this many universities. In my second clusters I have this many universities. In my third cluster I have this many universities. Okay, so I can now find out the average. Okay, how to find out the average in Excel? Simply by using this command. Okay, and see, this is the average for each and every, you can say that, the column. In the same way you can just use this and you can find out the average. Okay, and see here, this is the average. Okay, so in the same way I just find out the average value. Okay, see, this is the average for all three clusters. Okay, so in the same way, okay, I just use the here median. I can even use, okay, I can use the mean value. Okay, sorry, this is not the term here. See, let's run this, and this is the mean. Okay, for each and every cluster. Now you can even go ahead with this mean. So see, okay, for getting the admission in the like, let's say this cluster, zero clusters university, okay, means this many universities. See, okay, the CMU, Penn State, okay, Purdue, okay, Texas and Texas A and M, okay, Michigan, and University of Wisconsin. Okay, so if you want the admission, okay, in this many different universities, okay, or one of these universities, you want this, okay, this plus SAT score. Okay, now this is a accepted criteria. This is the SF ratio. Okay, and this would be the budget, means the expenses. Okay, for these for the universities. Okay, and then you can say that you want this much amount, this much like, you can say that percentage in the in the graduation. Okay, so now can you say that which cluster is the tier 1 cluster, which cluster is the tier 2 cluster, which cluster is the tier 3 clusters? Okay, so see, from like, according to me, this is, you can say that here graduation rate is quite high, 92. Okay, expenses is also quite high, then the SF ratio is low, acceptance ratio is always is also low. Okay, then top 10 is quite high, and the SAT score, okay, is also high. So according to me, this cluster is a tier 1 universities. Okay, means here in the clusters 1, okay, in the cluster 1 we have this much university. Okay, so means these universities are from the tier 1 universities. Okay, now you can say that this is the tier 2 universities. Okay, means cluster 2. Okay, in that cluster those universities we have, those you can say that tier 2 universities. Okay, because here you see the graduation rate is 89, the expense is uh, you can say that the medium, and the SF ratio is quite big as compared to this, and acceptance ratio is quite you can say that a bit high. Then top 10 is 81, and then SAT score is 1271. So you can say that this is the second clusters or the tier 2 universities. Okay, so you can say that this is the tier 2 universities. Okay, and lastly you can say that this is a tier 1 tier 3 universities. Okay, so now, okay, depends on your graduation rate. Okay, you can able to it depends on your financial background. Okay, because of the expenses column, then SF ratio, acceptance ratio, top 10, and the SAT score. Okay, so you can just choose one of the university for any tier. Okay, like a tier 1, this one, or this one, or this one. Okay, or simply instead of filling the form for all the universities, you can simply calculate, find out the your graduation rate, you can just manage that much of expenses and the SAT score. So you can simply say that, okay, if you have the SAT score which is very much close to this, so you can simply go with this university as well as the graduation rate. Okay, then you can able to manage this much of expenses. Okay, means the median value, sorry, mean value. Then you can go with this tier 1 universities. Okay, you can just fill the form for these universities only instead of all the universities. See, this is how you can use a clustering. Now you can apply the different single linkage clustering method on your data. Okay, now let's go and create the another dendrogram for this single linkage. Okay, so any questions up to this? Any questions, guys? Okay, so let's go and just build the find the clustering or the different clusters by using the single linkage. So basically we are just here just finding out the distance matrix, and in this cell we are finding out the dendrogram. Now you see the dendrogram. Okay, now it's here in the single linkage we are using the minimum distance, so that's why it look like this. Okay, you can see this is very much comfortable. You can even say that this many number of clusters you can form, okay, from this complete linkage. But now here you can see that by using the linkage single linkage clustering. Okay, now it is a little tricky to say that the number of clusters you want to form. Okay, now I'm using the agglomerative clustering, okay, for just making the clusters. So see here, I'm again importing the agglomerative clustering, and this is a clustering and clusters equal to 3. Okay, means I want to form the 3 clusters by using the single linkage, by using the Euclidean distance matrix, and I'm fitting this model, this clustering model, on my normal data. Okay, means my transform data. And then this is how labels of single linkage looks like. See, now you see most of the you can say that most of the data points which belongs to this label 0 means this one cluster, and only 2 data points which belongs to this different clusters. Okay, 1 or 2, because here see, if you split if you just cut your dendrogram from here, so see this is one cluster with index data point 2, this is another cluster with index data point 17, and this is your remaining clusters with these many data points. Okay, so again here I'm creating one new column which is a single linkage column, and this is how columns look like. So now we have the single linkage column, we have the complete linkage column, we have the university column. So now you can compare these 3 columns. Okay, because you have the complete linkage, single linkage, and university collab. Now you have to find that, okay, from which linkage method, okay, with like is good for your you can say that your analysis. Okay, so again here I'm using the group by function, okay, and to find out the mean. Now you can say that which cluster like which cluster is the tier 1, which cluster is the tier 2, and which cluster is the tier 3 universities. Okay, you can say that. Anyone, just drop the message in the chat box. Okay, so see, basically here you can see that this is a single linkage. Okay, this is a uh, first cluster. Okay, you form, see the graduation rate, this, see the SAT score, see the top 10. Okay, so according to your choice, okay, and your data, expenses, graduation rate, and the SAT score, you can find out the which cluster is good for you. But here you can see that this is the, you can say that the tier 1 cluster or the tier 1 universities, okay, clusters. Then this is the tier sorry, this is the tier 2 universities cluster, and this is the tier 3 universities clusters. Okay, again you can simply just save this file. Okay, so for that I have to just delete this. Okay, so let's go. Now see, here I got the error because, okay, I just, yeah, any question? Okay, so see here, basically actually I'm using this file now, so that's why I got the error, which is okay showing as a permission error. Okay, so let's go and run this again. Now see, okay, I'm able to run this particular cell. So see, at the end I'm able to create the different university into different cluster. Now see, this is not important. Okay, and sorry. Okay, now see, this is the single linkage, this is a complete linkage, and this is the university. So you can just drop this. Okay, and you can go ahead with this. Okay, just try to apply the sorting. Okay, and see here, after applying sorting, you can just again just go with the same steps. Okay, so according to me, this is not good clustering. Okay, because here you see, in one cluster, okay, I got one data point, in another cluster I got another data points. Okay, so I can say that just go with complete linkage or go with average linkage, okay, or the watts linkage. Okay, then you will get the best, you can say that best clusters with different universities. Okay, so any questions guys related to this, or shall we stop?